Hello calculus students. In this video we're going to explore a trigonometric limit that is akin to the fundamental trigonometric limit. That was the limit as theta approaches 0 of sine theta over theta. However, you see here we have the reciprocal of that. And something I want to point out, let me just do a quick note here. If we think about reciprocals, remember if we have a fraction like 4/5, remember, that is the reciprocal of 5/4, and we could write the reciprocal this way, 1 over 5/4. So that means that theta over sine theta, which kind of acts like our 4/5 here, this is the same as the reciprocal of sine theta over theta, or 1 over sine theta over theta. So let's put that to use in this limit. So I have 1 over sine theta over theta. Now, upon inspection, you might have been thinking, wait a minute, as theta approaches 0, I will get 0 over sine 0, so I'll get 0 over 0, that's indeterminate. All right, and then you can already see what the answer is going to be. As we approach 0 from the left, the function is approaching 1, and as we approach 0 from the right, the function is approaching 1, so the limit should be 1. And now we're going to put the final touches on this. The limit of a quotient is the quotient of the limits as long as the denominator does not go to 0. And then you will know from a previous video that the limit down here, this is 1, that's the fundamental trigonometric limit, and this is a limit as theta goes to 0 of a constant, which is simply 1. So we get 1 over 1, and that is 1. So we've just verified, and I'll write it down here, that the limit as theta goes to 0 of theta over sine theta is equal to 1. So we're going to put that to use in the next example. I can make that a better theta, I suppose. Okay, so the limit of theta over sine theta is also equal to 1. Okay, so let's go to the problem. And what happens if you're faced with something like this? We have the limit as x goes to 0 of sine 5x over sine 2x. Now, recall, we already know that the limit as theta goes to 0 of sine theta over theta equals 1, and it works as well for the reciprocal. Okay, so we have this information that we will put to use. All right, so let's break this fraction up. Let's write this as sine 5x over 1 times 1 over sine 2x. All right, so I'll write my limit. X goes to 0. Sine 5x over something. And I'll write the sine 2x. I'm going to leave the denominator numerators blank for a moment. And all right, what I'm going to do here is I want this to be a 5x, and I want this to be a 2x, because then I will get the same thing in the argument here as I do in the denominator, and here I'll get the same thing in the numerator as I do in the denominator, so then I could put these limits to use. Okay, well, I can't just multiply by a 5 here and a 2 here. The x's will cancel. So I need to multiply by 1 so I don't change the value of this limit. So I'm going to multiply this by a 5. I'm going to multiply this guy by a 2. And then I'm multiplying by 2 times 5 times x and 2 times 5 times x. So I haven't changed the value of this limit. And now, just as I've done with previous examples, I'm going to pull this 2 out as a 1/2. And I'm going to pull this 5 out and put a 5 there. And then I have the limit of sine 5x over 5x times 2x over the sine of 2x. And then I have a 5 halves, and the limit of a product is the product of the limits. And then I will employ the definitions or the results that we have here, and I get a 1 for this limit, and I get a 1 for this limit, and then I get 5 halves times 1, and I get 5 halves. All right, good luck.